Hey guys, welcome to section 2.4. We're going to talk about the product and the quotient rules. We're also going to talk about higher order derivatives. In particular, we're going to talk about acceleration, which is a form of physics. This section has a lot of procedure with it at the beginning and then a lot of concepts at the end. That's why there's an extra mini lesson out there to talk more about the physics part of it. Okay? For right now, let's just focus on the product and quotient rules. First of all, product means multiply and quotient means divide. Last time we talked about add and subtract, so let's start with the product rule. The product rule, it is u dv minus v du. That looks really confusing. Okay? Basically, it means first times the derivative of the second plus the second times the derivative of the first. It is not just the derivative of the first thing times the derivative of the second thing. It's first derivative second plus second derivative first. Okay? One of the most forgotten rules. It is multiplication, so it needs a rule. It's not just the derivative of the first and the derivative of the second. Let's try one, because we're not going to get it unless we try it. This is a product rule. How do I know? Because it's two different things multiplied. The product rule says it's the first, x squared plus 3, times the derivative of the second. Well, what is the derivative of the second? That's 6x squared plus 5. First, derivative second, plus second, 2x cubed plus 5x, times the derivative of the first. Well, what is the derivative of the first? Well, it's 2x, and the derivative of the 3 is just 0. If it's a short answer test, you're done. Unless I say simplify, which I'm going to make you simplify now just because you need practice. Distribute out here, FOIL, you get 6x to the 4th plus 5x squared plus 18x squared plus 15 plus 4x to the 4th plus 10x squared. Let's clean that up. So the derivative is 10x to the 4th, gone, gone. 5, 18, and 10, that's 23, so that's 33x squared. Gone, 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 and then plus 15. So that is your derivative. Let me stress this. I'm not going to give a lot of examples in this little short video of notes, but we do a lot in class, and we're going to do a lot more practice. First, derivative second, plus second, derivative first. You will mess up a problem because you do not do product rule. It's going to happen. So just make sure you're very careful. Well, if that's product rule, here's quotient rule. V du minus u dv over v squared. Really complicated way to think about it. Here's the way I do it. Bottom times derivative top minus top times derivative bottom, all divided by bottom squared. Bottom derivative top minus top derivative bottom over bottom squared. If it's division, you have to do quotient rule. If it's division, you have to do quotient rule. You cannot just take the derivative of the top and bottom. You have to follow the rule. Let's try a practice problem. Okay? It's division, so we're going to do quotient rule. Bottom, x squared plus 3. Derivative top. The derivative of the top is 6x plus 5. Minus the top, 2x cubed plus 5x, times the derivative of the bottom, 2x. All divided by the bottom, let's use blue for the bottom. The bottom squared. So that's quotient rule. Don't leave it like that, clean it up. You can leave the bottom be, clean the top up. That's 6x to the third plus, oh, I'm sorry, no, I messed up. That's 6x squared, isn't it? 6x squared. So that makes 6x to the fourth plus 5x squared plus 18x squared plus 15 minus 4x to the fourth minus 10x squared. Okay? Clean that up on top. We did this problem earlier, but it's going to have minuses with it now. So that is 2x to the fourth, go on and go on. 23 minus 10 is 13x squared plus 15, all over top of x squared plus 3 quantity squared. Quotient rule. Again, there's many more examples in the practice problems, in the homework, and in the notes in class. But I just want to give you a brief overview. That's product rule and that's quotient rule. Multiplying and dividing. Higher order derivatives. This chart is just a way of saying that you can take a second derivative. You can take a third derivative. Once you get past 3, don't put 4 little apostrophes up there, put a parentheses 4. Don't put a 4 because it looks like y to the fourth. So all I'm doing to do a higher order derivative is just take the derivative again, take the derivative again, take the derivative again. So let's try this problem. There's the original. I want to find g double prime and g triple prime, or the second derivative and the third derivative. I can't do that without finding the first derivative first. So let's find the first derivative. I don't like the way this is written. Let's rewrite it. Remember, I like number, letter, exponent. What is the number that goes along with this? What's the constant? It's negative 1/2 x to the fourth. The rest of them are okay. We're lucky. This is not a product rule and it's not a quotient rule. It's very simple. It's just power rules. So g prime. Multiply 4 down, you get negative 2x to the third, 9x squared, minus 2. But that's none of the questions that I asked. Now g double prime. Take the derivative again. Negative 6x squared plus 18x. The minus 2 goes away because there's no derivative of a constant. So that's the second derivative. Third derivative, take the derivative of that. Negative 18x plus 18. Question, if I keep taking the derivative, what's eventually going to happen to my thing? It's going to go away and you're going to get 0. If you have a polynomial and you take enough derivatives, you're going to get 0. Okay, why are we doing this? What are higher order derivatives? I know the first derivative is rate of change, so what would the second and third and fourth derivatives be? We use them in physics. Okay, physics. Remember, there's an entire mini lesson out there dedicated just to physics. So focus on that if you're having trouble with this. You already know that the derivative of the position function is the velocity function. Remember, position is s, and if I take the derivative of position, I get velocity. Why? Because velocity tells you how fast you're changing. I'm going 60 miles per hour. Well, the derivative of the velocity function is the acceleration function. So I know that the derivative of the velocity function is the acceleration function, which is the same thing as the second derivative of the position function. They're all connected with derivatives. That looks confusing, so I made a nice little pretty chart for you. If you have position and you take the derivative, you get velocity. If you take the derivative again, you get acceleration. Okay? Little tips to help you with the physics problems. Find the position, the velocity, and the acceleration functions first. They give you position, take the derivative, find the velocity, take the derivative, find acceleration. Write that down, put it off to the side, it'll help later. Remember, average is 2 points, instantaneous is 1 point, or derivative. Average velocity is 2 points from position. Instantaneous velocity is plug x into velocity. Average acceleration is 2 points from velocity. Instantaneous acceleration, plug in the x value into acceleration. Complicated. That's why I wrote an extra mini lesson for you, and that's why I've given you a lot of practice problems in class. When an object is at its highest point, the velocity is 0. That is a huge concept. When something is at the top and it's not going up anymore and it's not coming down anymore, for 1 instant it stops, the velocity is 0. So if you take the velocity and set it equal to 0, this will tell you when you're at the highest point. It takes 6 seconds to get to the highest point. If you want to know where, you plug that back into the position. Let's try some of these. Well, this can get tricky. Average versus instant. If I have position, so I have S of t, how do I find instantaneous position? Well, I have position, I want position, I just plug in t equals to position. Really easy concept. If I want to know where I am at 5, I plug in 5. How do I find average velocity? Well, velocity usually means derivative. But when I see average, that means I don't want the derivative. That means I want 2 points, and derivative means slope. So I want the slope between 2 points. So slope between 2 points from the position. I can't use the velocity equation. I don't know it because I don't use the derivative. So I want 2 points. How about the instantaneous velocity? Now I know that instantaneous velocity means derivative. So I want the derivative of position. So I take my position, take the derivative of it, and that's velocity. This relationship between position and velocity also holds true for velocity and acceleration. So how do I find the instantaneous velocity? I plug t into the velocity equation. How do I find average acceleration? Well, normally I would take the derivative. But because it's average, I want the slope between 2 points. Now, which function do I plug those points into to get it? Well, if I have velocity, I want 2 points from the velocity equation. I can't use the acceleration equation because I haven't found it yet. I didn't do the derivative. What if I want instantaneous acceleration? Instantaneous acceleration, that's the derivative. Which is also the second derivative of position, just in case you need to know. Remember the chart. Position, velocity, acceleration. Quick physics note. What's the difference between velocity and speed? Well, speed tells you how fast something is traveling, miles per hour, feet per second, whatever. Velocity tells you not only the speed, but what direction. So 60 miles positive is 60 miles forward, 60 miles negative is 60 miles backwards. Or it could be up and down. So velocity has sign and number. Speed is just number. Speed is the absolute value of velocity. But they do have the same units, miles per hour, feet per second, whatever you're talking about. So if I ever ask you for the speed, it's just the velocity but with absolute value. Let's take a look at this. Graphs are where people have trouble. The first thing you need to know is what kind of graph is it? It's a velocity graph. What's the velocity at 1? Well, this is a velocity graph. So just look at the graph. How fast am I going at 1? 1 feet per second. How about at 5? -2 feet per second. Those are easy. The velocity graph, just look at the graph. Ooh, speed at 8. Here's 8. The velocity at 8 is -1. So then what's the speed at 8? It's +1. Because speed can't be negative. Speed is always positive. What is the acceleration at 6? Okay? If I have velocity and I want acceleration, what's the relationship between velocity and acceleration? It's the derivative. But I don't have an equation to take the derivative of. I have a graph. What is derivative on a graph? What's another word for derivative? Slope. So I want the slope at 6. I don't know how to find the slope at a point, but I got lucky. What shape is 6 on? What is that? That's a line. Lines are easy to find the slope of. It's rise over run. How far up did I go? I went up 1. How far over did I go? Over 3. The units for acceleration are feet per second squared. Derivative, because it's acceleration. Slope, because it's on a graph. When is the particle moving forward? Well, it's going forward. What tells you whether it's going forward or going backwards? The velocity tells you that. How do you know it's going forwards? The velocity is positive. Look at this graph. This is velocity. So when does this graph have positive numbers? In other words, when is this graph above the x-axis? So I want to know when it's above the x-axis. Well, right here. From 0 to 4. It's above the x-axis. When is it going backwards? What does backwards mean? It means the velocity is negative. This is a velocity graph. So when is this graph negative? The graph is negative when it's below the x-axis. When is this graph below the x-axis? So I want below the x-axis. From 4 to 8.5. Now why can't I include 4 and why can't I include 8.5? Because at 4 and 8.5 it's not above the axis and it's not below the axis. It's on the axis. What number is on the axis? 0. If the velocity is 0, what's that tell you about your movement? Is 0 going forward? Is 0 going backwards? Neither. 0 means you're standing still. When does the particle stop moving? When it's on the x-axis. So when's it on the x-axis? At 0, at 4, and at 8.5. Okay, tough problems. When is the particle speeding up? Well, remember, you speed up when your velocity and your acceleration are both in the same direction. So you're going forward and you're being pushed forward, or you're going backwards and you're being pulled backwards. It's when velocity and acceleration are in the same direction. Okay? I want to know then when the graph is above the axis, and what does acceleration look like on this graph? Remember the last problem we did? What did acceleration look like on the graph? It was slope. So I want to know when the graph is positive and the slope is positive. So this is when the graph and the slope are positive. When is the graph and the slope positive? Well, this is the graph is positive, but only this part is the slope positive. So from 0 to 2. Or they could both be negative. They could be going backwards and being pulled backwards. So when is the graph negative and the slope negative? Right here, 4 to 5. What about slowing down? Slowing down is when your slope, when your velocity and your acceleration are opposites. So like going forward but being pulled backwards, or going backwards and being pushed forwards. So what does that mean on this graph? It's where the graph and the slope are opposites. In this case, this is a positive graph with a negative slope. So from 3 to 4. This is a negative graph with a positive slope. But I cannot include this point 8. If you remember back in section 2.2, we talked about where you don't have a derivative. What is this point? It's a corner. It doesn't have a derivative there. So it's 5 to 8 and 8 to 8.5. I cannot include the corner. Speeding up and slowing down is some of the hardest concepts for people to get. Again, that's why they have their own mini lesson dedicated to them. Okay guys, that's it for this section. This is a very, very, very detailed section. There's a lot to cover in this. There's a lot of mini lessons associated with this. So if you have questions or problems, especially with the graphs, because that's where most people struggle, come see me. Okay, before school, after school study hall. Thanks.